Welcome back to Maths Masters. So we're going to look today at decimal numbers. So why do we have decimal numbers? Okay, so I've got on here lots of different examples of places you may have seen decimal numbers in everyday life. So pause the clip, have a look at all those different places and talk about if you have seen decimal numbers used in these contexts as you've gone about your life. Okay, so you may have seen decimal numbers used when you're weighing yourself. You may have used them when measuring the length of something or the height of something. You might have seen them used when you're finding the distance from one place to another. Sometimes it's on the sat navigation system in the car, it might be on the phone. Sometimes you see it for prices, you'll see decimal numbers used when we have pounds and pence. Timing of things, if you're using timer on your phone and iPads, a stopwatch, the computer. And you might see decimal numbers used when we're weighing things such as ingredients as well. You can also see if you have an alarm clock, you might see the decimals used there as well. Okay, so what are decimal numbers? So decimal numbers are parts of a whole number. So we can have whole numbers and parts of a number, and those parts are decimal numbers. And we use them when the whole number doesn't give us enough accuracy. So when we're weighing ourselves, we might not exactly be so many kilograms or so many pounds. So we need to be able to see what those little bits extra are. And when we're looking at the length of something, particularly when we're comparing lengths, we might want to be able to look at this length of something and measure it in centimetres and millimetres so that we can see how many centimetres, how many parts of a centimetre one is longer than the other. A great example of this is a shoe size, okay? So often we're not a whole shoe size. Our shoe sizes, they go 1, 2, 3, 4, 5, 6, 7. They keep going like that. And sometimes you might be not a 5, I'm in an adult size, I'm not a 5, but I'm also not a 6. So I'd say that I'm a 5.5 or a 5.5. So I'd use a decimal number to describe that shoe size. So it's not a whole one, it's somewhere just after a whole one, but doesn't go to the next whole one. Okay, let's look at this a bit more. Okay, so talking about weight at first. This person weighs 124 pounds and 6 ounces, or 124.6 pounds. So they're not 124 pounds because they're a little bit more than that. And they're not 125 pounds because they're a little bit less than that. So this 0.6 is a way of describing that a little bit extra than the whole one that they are. So they're 124.6 pounds. Now converted that into kilograms, kg, the person is 56.5 kilograms. So they're not 56 and they're not 57. They're a little bit more than that. So we need more accuracy than just the whole number if we want to measure their weight really accurately. So 56.5 is halfway between 56 and 57. So it gives us a little bit more accuracy about their weight. Shoe size we've just looked at. Have a look at your shoe size. So your shoes might be written as 3.5, or it may be written as 3.5. So we're a half and 0.5, a decimal number and fractions there, they are parts of whole numbers. They're a way of being more accurate about things. So here I was measuring the heights of 2 candles. So the first candle and the second candle are very similar in their height. They are both 9 whole centimetres, but the first one is 9 whole centimetres and a little bit more. It's 9.4 centimetres. The second candle is 9 whole centimetres and it's a little bit more than the first one. It's 9.9 centimetres. So it gives us a little bit more accuracy, so I can see that this one is slightly bigger than this candle. When we're looking at distances, you might hear about people running a marathon, and a marathon is measured at 42.2 kilometres. And it isn't 42 kilometres. If you only ran 42 kilometres in the marathon, you'd be a bit upset because you just missed off 0.2 kilometres and you wouldn't get the medal, you wouldn't cross the finish line. So that extra 0.2 kilometres makes a difference. And if you're running that distance, that extra 0.2 does make a difference. In miles, 42.2 kilometres, a marathon, is 26.2 miles. So again, that 0.2 miles, it's not quite a whole mile you've got to run after you get to 26 miles. It's a little bit more, but you still have to run that to be able to complete the marathon. So it's a little bit more than a whole mile. Again, I was looking at a distance to go from home to school. I was going on my bicycle from home to school and I measured the distance and it came up as 4.8 kilometres. So I travelled 4 whole kilometres, but it wasn't quite 5 kilometres. If we look at that on a number line, 4 whole kilometres I travelled, but it didn't quite go all the way to 5 kilometres. So I stopped about here at 4.8 kilometres. So it's a way of measuring something that isn't quite a whole number. We use decimals in our money system as well. Pizza here is £4.50. This pizza at this stall is £4.75. So they both cost 4 whole pounds, but we can look at the decimal numbers that aren't quite whole pounds, the parts of a pound, and to see how many pence, how many parts of a pound they differ. This one is £4.50, so it's 4.5 of a pound, and 4 whole pounds and 0.5 of a pound, and this one is £4 and 0.75 of a pound. So this one is more expensive, this costs more pounds because this is closer to 5. And if we look at those on a number line again, we've got 4 and we've got 5. 4.5 would be halfway along, so £4.50, and £4.75 would be 3/4 of the way along to get us to 5. Okay, so they're not quite £5, but it's a way of talking about parts of numbers. In the description section for today's session, you'll find a link to an Olympic race. It was in 2006 and it was a 100 metre race with Usain Bolt, Justin Gatlin and Andre de Grasse. And when you watch it, watch the video clip and they are timed to check the time of their race. Now this is really important when you're racing because you're trying to always, if you're competing, you're trying to make your time smaller. You're trying to run the race in as least amount of time as possible so that you cross that finish line quicker. And if we measured it in just whole numbers, that race, it's measured in seconds, and these guys could run those whole 100 metres in 9 seconds. But the problem is here, if they all ran it in 9 seconds, how do we pick who came first? Who gets the gold, who gets the silver and who gets the bronze? It's impossible to do that. So what we need to do is work out exactly, because these guys are running so close together, we need to go beyond a second. We need to look at parts of a second. So we need to look at the decimal numbers to see what they ran the race in to be more accurate. So Usain Bolt ran it in 9 seconds, 9.81 seconds. Justin Gatlin ran it in 9.89 seconds. And Andre de Grasse ran it in 9.91 seconds. So that means Usain Bolt finished it fastest. So he won gold that year in the Olympics for running the 100 metres. So you can see, when you watch that video back, you can see how close they are crossing the finish line. But that little 0.08 of a second makes a difference between coming first and second. So he will be working after this race and trying to make his time closer to this. So watch that and have a look at how important those decimal numbers are for working out very close races. Once you've done that, I want you to have a go at something else. Guess the length of a minute. So use your iPhone, use an iPad, use the timer, use a stopwatch, or get someone to time it. And what we should do is press the timer, the stopwatch on your iPhone or your iPad, and close your eyes and count and see if you can think how long a minute takes. And press stop and open your eyes and see what time you've recorded. You might see something like this. Okay, and it might be that you stopped it at not 1 minute, you've stopped it at 0.53 minutes. So it's not quite at a minute, because 60 seconds makes 1 minute. So you might have stopped it just before, not quite at a whole minute yet. So have a go at that and keep playing around with it. See if you can try and stop it exactly on a minute, and just look at how the decimal number is used to help you see when you're slightly over a minute and when you're slightly under a minute, when it isn't a whole minute that you've managed to count to. Okay, so we'll have a think about those. Have a look out for decimal numbers as you go around. See if you can see any in your house or in your school, and share them with your friends and talk about those. And I'll see you back in the next session where we'll look at recognising how we talk about these decimal numbers. What name do we give these decimal numbers? I'll see you back in the next session. Thank you. Bye.